it's Steve, and this is Brainless Raider, a puzzle adventure game made in 3 hours for Trijam 276. In this series, we're going step by step over the process of remaking the game in Bevy, the Rust game engine, in probably closer to 3 months. Last time we created an audio server for use by sound effects and the background loop, so basically all over our project. And we also consumed that for our goblinoid collision and the treasure collision, as well as the background loop. Today, we are going to do some more work around this treasure collision to try and get it picked up and actually following the movers around in a nice little train. We'll start in the same spot we always do and create a quick module. Alright, we're including that treasure train plugin and defining it, which of course is not doing anything yet. Let's see, what do we need to have in here? We're going to have a couple of components, and we're going to have a system to update the treasure train. So let's add those chunks. First component we're actually going to put in here is we're going to grab our treasure that we defined in the collision events earlier and move it over here. Now, we might need to add some properties to this treasure, or we might not need to. I suspect we won't, so we're just going to leave it like a tag for now, but this is also a better place to put it than collision events anyway. So effectively, what we want to do upon our first collision with the entity is we want to spawn a treasure train entity that keeps track of what the treasure train's doing. That way we can update that treasure train separately from the movers. So let's start by creating a treasure train entity, now that we have our references here. And so here we have our mover entity, which is the thing that this treasure train is following. We have our set of treasures, which are all the treasures that are being held by this treasure train. We have the head spot, which is effectively where the first treasure would be following from the mover, which is, it's basically going to be kept in sync with where the mover is moving from, so that the treasure can be following along behind the mover. And then some target spots to hold information for all of the other treasure behind the mover. So the first thing we're going to do in this collision, other than make a noise that we're picking something up, is we're going to try and figure out whether or not the mover has a treasure train. And in order to actually find that treasure train, we're going to need a query to find it. So let's do a mutable query up here too, which we are going to immediately use right down here to see if we can grab a treasure train. So here we are checking the TR mover, which is that property we just set up on the treasure train, and comparing it with the mover entity that's currently colliding with the treasure. So we're basically going through all the treasure trains that exist, asking, hey, is this treasure train assigned to the mover that's currently colliding with this treasure? And if so, that's the one that we care about. If not, then, keep on looking. And if we don't find anything, that means that we're creating a new treasure train. If we do find something, then that means we can append ourselves to the back of the current treasure train. Let's make that pair of cases down here. We need to actually pull the treasure entity from that OK statement in order to assign it into those treasures. Alright, a couple of things we need to do right quick here is we actually need to make target and coordinate on mover public fields. So let's do that. So those are able to be adjusted and checked. Now, when we do find one, we push the treasure entity into the treasure train. That's pretty straightforward. If we don't find a treasure train, we have to make our own. So the mover is, of course, going to be whatever mover we just collided with. The treasures is going to only be one. Since there isn't a treasure train already, we can say for certain that we are the only one that is currently making up this train. The head spot is going to be the mover's target. So I misspoke a little bit earlier. It's not actually where the mover is moving from, but where the mover is moving to that the head spot's at. But the target spots are going to be what the treasure entities are actually moving towards, so that they can always stay behind the mover. So then that would be mover chord, which is where the mover is moving from. So that was a whole lot of setup. We still don't have our treasure trains moving, but what we can do is real quick check that this is working by making a system in treasure train to just query over all of those and just tell us how many there are, basically. So here's the signature we're going to be using to update the treasure trains. Of course, now we're just going to be logging things, but just to go over it real quick, obviously we're going to need to update the treasure trains themselves, which means updating where the target spots are primarily, and the head spot, keeping those in line. We're also going to need a mutable query for the treasures so that we can loop over the ones that exist in our treasure train and move them over time. And then we're going to need a non-mutable reference to our movers so that we can figure out who we're following and then use that data to inform our head spot and target spots. But for now, what we're going to do is just log effectively how many treasure trains are currently active. So that should be good enough to do that. Let's see what happens. We're not getting any logs, and the reason for that is because we did not include our update in our app. Whoops. Alright, let's try running that again. So right now there's 2 treasure trains. There were 0, and then goblinoid entered the treasure and it became 1. And then adventure entered a treasure and it became 2. That's working more or less as expected. Potentially some of this is a little bit broken, but for now, I think waiting until we can see that happen is going to be the right play. But the treasure trains are being created, so let's get them rendering and make sense of what's happening. So we're going to loop through all of our treasure trains that exist, and we're going to make sure, first of all, that our targets are up to date. So what we're doing here is first making sure that we have all of the target spots synced up with the number of treasures we have. The next thing we're doing is finding the mover that's associated with that treasure train and comparing its target, which is where it's moving to, with our current head spot. If those match up, then we know that we are caught up as far as target spots with where the mover is. Otherwise, we basically propagate downwards that position through our full list of target spots. So that iterates from 0 to length, but in reverse. So the end of length to 0. If there's 3, it'll go through the third one, the second one, and then the first one, and it'll just grab whatever was previous in that list of numbers and move it. So let me actually showcase that using a notepad here. So let's just work in one dimension right now. We'll say the mover's at position 1, and treasure train, it's got a head spot and some target spots. The head spot is going to be from the mover's target. The target of the mover is at 1, and the coordinate of the mover starts at 0 or whatever. So the mover's moving from 0 to 1 right now. So the treasure train sees that, and it sets its head spot to 1. And there are 3 treasures in the treasure train, we'll say. Say they all start at 0. So it looks through and says, okay, 0, well, that's still 0, and that's still 0, but if I look up to the head spot, well, that's 1 now, and that's fine. But the mover's at 2, so now our head spot's at 2. So then we go through again, and the mover has updated to 3. So the 0 stays here, 1. Now this looks at the head spot and becomes 2, and this looks at the target and becomes 3. And that's how it kind of propagates to follow in a train-like manner. So again, just one more time, 4. So now that becomes 1, 2, 3. And now that's 4, and so on and so forth. That's how the train works to kind of follow the mover around. So the final thing to do here is actually to use these target spots to inform where we're moving our treasure to itself. So, because right now, if we ran this, there wouldn't be any movement, because all we're doing is updating our references to the IVEC2s here, which are the coordinates where we're positioning our treasures, but we aren't positioning our treasures yet. Let's go through and move our treasure. So talking through this real quick, we're going through all of the treasure entities in our treasures list, which we just talked about is synced up with the target spots, which are now up to date with where they need to be. So we can use that iteration as our indexing into the target spot coordinates. So now we have a reference to what coordinate we're actually trying to move our treasure to, and then we can do a simple movement calculation here, which effectively takes where we are and where we're we're going to, finds the vector between those two, and then uses that to move given a speed, which the speed is currently hard-coded to 0.1. Eventually, we'll probably want to move that to a constant, but for now, we're fine with that. So that should be enough to see these treasures move. Let's see. And there we go. There's a little bit of funkiness going on here, as you see. There's a few issues happening. If you listen closely, you hear that the adventurer is picking up and re-picking up this treasure. Also, I believe that treasure is still part of the dead goblinoid's treasure train, which is why it's hanging out over here rather than where it should be, which is somewhere behind the player. So how do we solve those issues? The first thing that we need to do is to remove a treasure train entirely when an entity dies. So let's get started with that. Currently, the only time any entity dies is when the adventurer and goblinoid collide, which is here. Eventually, we want to move this into something else. We'll talk about that when we get to it. But for now, we're fine putting it here because when we do eventually move this code, we'll all move it all at once. So that's quite all right. We also need to grab whatever treasure train might belong to the goblinoid. And where we're going to do that, we might as well do it right at the top of here, because if this happens, we know we're killing something. So that'll remove the treasure train when the goblinoid dies, which should be enough to get the treasure train moving in a way that makes a little bit more sense to start with. So let's look at what that looks like. See, for now, that's looking alright, but as soon as we go back, we see that we actually re-collide with these treasures, and that causes all sorts of weird behavior. It's a subtle weird behavior because of the way that map is laid out, but it's definitely noticeable. The thing, of course, that's happening there is we are re-colliding with those treasures, which then puts them at the end of the list, even though they're already earlier in the list. So now they occupy multiple places on the list and are further down generally than they need to be. So one easy way to fix this would be to remove the collider on the treasure when it's picked up. The issue with that is that we actually need to re-enable that collider when it's dropped. And, sure, we could instantiate a new collider, but it'd be better to instead use a tag. So that's what we're going to do. So let's define a real quick and dirty tag up here for collision disabled. And actually, we're going to put this in the collision system itself because that's where we want to handle that. And basically what we're going to do is if there is something with this collision disabled, we're not going to worry about updating that collider. One easy way here is to just chuck a without in here. So we are saying effectively this is a query of all of the colliders that don't have collision disabled. Problem with that is if there was currently collision happening, that would cause some issues because then it wouldn't be so much like the thing was being removed from the collision space. It would be more like the thing is still colliding with everything it happened to be colliding with at that moment in perpetuity. With the way that this works now, that's totally fine. When we run into an issue with it, we'll fix it later. Now that we have that, we can actually insert that into the treasure as soon as we collide with it. So here-ish. We'll make a sound as if we're picking it up, and we'll also disable the collision. And then we'll also want to reinsert that down the line. If this is working the way we expect it to, both of the entities will pick up their treasures, and then after the goblinoid dies, its treasure will not be pick-upable. Let's check. There we go. And that is in fact what happened. Rad. So all we need to do then is to remove this collision disabled when the goblinoid dies. So let's go and do that. So here we're going through all of the treasures on the treasure train that is associated with the goblinoid entity. And then removing the collision disabled from them. So basically adding them back into eligibility for being picked up. So let's look at that behavior. There we go. We're picking up both treasures again. And when we walk back through our treasures, they continue following us as a treasure train. If you go back in the video and compare this with what was happening before, you'll be able to see why I was saying this was an issue. That's more or less all we can do here. Down the line, I'm definitely going to refactor some of the treasure implementation. There's 2 main issues with it currently at the end of this video. Issue 1 is in later levels, there will be situations where you'll want to have basically moved over top of the goblinoid to defeat them, thus picking up their treasure, but the goblinoid and adventurer are coming from different angles, so their treasure is actually over here, and the adventurer keeps moving on. That's, granted, could be something you can build a puzzle around. It's not something I found particularly interesting to build puzzles around. So instead what we want to do is when that happens, we want to just shift all of the treasures automatically following the adventurer. That's something that we can implement down the line after we do level transitions and stuff and actually see that issue in the game. The other issue with our current implementation is that it just kind of looks boring. So let's look at it one more time. It's moving and it's following and it's a little bit animated, but it's just static. It's not as fun looking as I would like it to be. So that fix is going to take place later when we start thinking about look and feel of the game, but just something else to hold on to in your brain, that there's going to be more stuff happening with these down the line. All right. That pretty much wraps up what we're doing today. Successfully got the treasures picked up and following the movers around, which is awesome. The next thing we're actually going to do is level transitions, because we actually have full interactivity other than the exit of the level with our first, we call it a level, but it's, there's no interaction on this particular map screen. It's more of an introduction to how things move. But next up, we're going to do collisions with exits and get started on thinking about level transitions. That'll include a little bit of scene management and some other things. Hard to say whether we're going to be able to do that in one video or if we're going to have to split it into 2 currently, but stay tuned next time to find out. Thanks for watching. Peace.